Hello and welcome to my video 2.4 on factors. So the last video was about multiples, this is about factors. They're very similar, they're related, they're kind of opposites. Like multiplication and division are opposites, these are basically those equivalent. So let's take a look here. Instead of looking at multiples, we're looking at factors. So multiples get bigger, factors look at what is the smallest or smaller versions, smaller whole numbers that make whatever the original number was. So looking here at prime numbers, we've got a couple different definitions here that we have to know. So we've got prime, composite, and we have factors. So prime numbers are numbers with only two factors. Composite numbers have more than two factors. And a whole number can be divided, factor, is a whole number that can divide the original number evenly, meaning that it only ends up with another whole number. So let's say 4 can be divided by 2, so 2 is a factor because it divides it evenly, giving another whole number at the end. Whereas if I tried to go 4 divided by 3, I'm not going to get a nice whole number. I'm going to get 1.3 repeating. So it's not a nice even whole number. And so we do not call 3 a factor of 4. Okay, so this is not a factor. Alright, so we have a couple definitions here. So prime numbers only have two factors. So usually that looks like this. 1 times 2 equals 2. There are only two numbers that can multiply to get 2, 1 and 2. That's it. You can't do 1 and 3, you can't do 1 and 4, you can't do 2 and 2, nothing else. So it's usually a prime. Normally we say 1 times itself. Whoopsies. Is the only, those are the only two factors. Okay? That's another easier way of looking at it. Okay, let's take a look at this question here. It says, list all the factors of 8 and then 24. So let's do 8 first. All the factors of 8. So we know 1 can divide 8 evenly. 8 divided by 1 is 8. And that means also that 8 is a factor. But there are ones in between. So let's go in between. 2 does do it evenly. As 2 times what equals 8? 2 times 4. Okay? And then you would check all the way until you meet in the middle. So in this case, does 3, so 1, 2, 3, does 3 divide 8 evenly? No, it does not. So 3 is not a factor, so we have our 4 numbers. Let's do that again with a different number. With 24, we can start right away with the two easy ones, 1 and 24. Then 2 times what equals 24? 2 times 12. Then 3, does 3 work? Yeah, 3 times 8 equals 24. And let's see, are there any more? 4 times, yep, 4 times 6. Whoa, oh, that's getting pretty small. 4 times 6 does equal 24. Does 5 times 5? Nope, 5 times 5 is 25. And so we've met in the middle, and we know that's the end. That's how you know you've gotten all the factors. Alright, perfect. Which of the following numbers are prime numbers and which are composite? So we've got 4 numbers here, and basically I'm just asking, are they prime or composite? Are there 2 factors or are there more? So basically you're just going to split it up into as many smaller versions of themselves as you can. This is only 1 and 2. Must be a prime. Okay? This one here is just 1 and 13. Must be prime. This one, oh, this one can do more. 1, it can do 3, it can do 5, and it can do 15. So this is composite. And this one here can do 1 and 27. So maybe we'll look at that, 27. And it can do 3 and 9. So this is also a composite. Alright, and looking at this last question, which of the following has a factor of 3? So we would just look at these ones and basically ask, which can be divided by 3? So Can 5 be divided by 3? Nope. Can 6 be divided by 3? Yes. Equals 2. Check mark. Can 13 be divided by 3? Nope. Can 24 be divided by 3? Yes, it is 8. Okay, so those are a couple different ways that I might ask a factor type question. It also might come up as a problem-solving question, as some of the textbook ones have come up, but they're the exact same concepts, same topic. All right, good luck.